All right, we are going. Well, welcome to your weekly webinar number 7 with me, Michael Floyd. I am your mentor and your mentee. You learn as much from me as I learn from you. Now, setting the pace for this course. Give me 1 second. I will. I hope the microphone is all right as far as the computer. I figured that I'd try the computer instead of the actual microphone for my headphones. But if that is a problem, maybe I'll just switch to my headphones right now. 1 second. Okay, so the headset is connected. It should be a little better to hear me right now. So, like I was saying, setting the pace for this course. Still, only 6 of you have completed the first project. That means 8 of you should email me as soon as possible and set up some calendar meetings. We need to get this project out of the way, right? The money is already spent. 30 minutes in the morning, 30 minutes at night. It should get you up to speed and you should be able to complete this course. Now, and also every time you spend on the course, just write a little bit on Slack about what you learned, right? Try to get your team involved as well. I was hoping it would be more of a team effort and you would have a lot more discussions going on amongst each other, right? I remind you every time you have a case of 3 students, right? Student A has 0 responsibilities, but we all are student B and student C, right? Student C makes sure that he stays consistent with the schedule and picks up slack wherever people ask him to pick up slack. Student B goes out of his way to make sure he has time for this course. All right? So with that being said, enough being said, let's try to be more like student B. And this webinar will be a walkthrough of the second project. I walked through some parts of the project earlier with using the PyTorch demo, but I will walk through a little more right now as well. So let me begin sharing my screen. All right, my screen is shared. Now, so this is the second project. So we will be developing a neural network that will be able to classify images. And what we will do is instead of just trying to find something that works as far as a network but as far as a network, we're going to load something that's already been trained before to handle a similar classification problem. And that is called transfer learning, and it's used a lot in neural network activity, right? It's a lot difficult to come up with your own architecture and much more easier to use architecture that's already been created. So with that being said, let's go forward to the lesson. So what we actually have is we have 102 flower categories, and we'll be using a large data set to characterize different images into the flower categories. So you have your import statement here. You will import everything you need. I believe this was, I already did this. I already did this in the PyTorch webinar. You have your matplot inline, you config. Right now, your matplot, pyplot is PLT. All these things that you usually need for your neural network that's going to be built using PyTorch. So you're loading the data here. Here are your directories. Let me make sure I run these cells. Okay, so that was run. And now you are at the load data cell. So it says to load the data. Here are the directories, and it also tells you that the data is normalized using these means and standard deviations as well. So what you're going to do is, of course, run it to obtain the directories, and you're going to define your transforms. Now it says in here that you need to resize to a 224 by 224, which is what this does right here. So it crops 224 by 224, and then transforms it to a tensor, and then normalizes it. Right, so that's for the train set. You want to do the same exact thing for your validation and testing sets. So I will copy this. I will paste this. Excuse me, this is a little background noise. So, like I was saying, all that is copied and pasted. So we have our transforming for the training, valid, and test sets. Now remember also there are things you can do like as far as data augmenting, but I'm going to skip that for now. That should be a part of my next lecture, weekly webinar. So all these data sets are properly transformed. Now we want to load the data sets into a trainer. Right, so we have did this for the train directory and added the transform. So we want to do this also for the test directory and validation directory. Test directory, and we have validation directory, and it transforms valid and transform test. Now for this one, the validation and testing are both similar to the training as far as the transform we're putting on them, but sometimes they are not, right? So sometimes perhaps you might have data augmenting in the training, and you do not augment data for the validation or the test sets. So that's why we have the different transforms right here going on. So, and now we want to load the data loaders that's going to allow us to iterate through and gather batches of the training samples. Now, I wanted to show you something. Okay, so if you go to the lesson 5, which is deep learning in PyTorch, the updated one, all you do is lesson 5, another lesson 6, and you go to, I believe, number 24, notebook workspace with GPU. All of the lessons are already here. I went through, I believe, all of these in the webinar for PyTorch, but since we are going to be using transfer learning, I want to, of course, use the part 8, which focuses mainly on transfer learning. Right, I will be using a lot that's going on here. So, just taking it from here, they have inputted their data. Actually did a little bit of data augmentation with the horizontal flip, and now they have a test set as well, and they did the same thing, passed it and got the training and testing data, and they called theirs the train loader and test loader. So I'm going to copy that and call it train loader, and we're going to also have a test loader and a validation loader. So, okay, and also let's name this test loader and name this valid loader. So now these are the loaders. What we're going to be doing with these loaders is iterating through these loaders, and that will give us a set of images and labels. When we're training neural networks and when we are finding the accuracy of inputting anything into neural networks, the major problem comes in when we have a really large data set. A really large data set of millions of images is impossible to conduct a feed-forward network through due to just the size and all the matrix multiplications and whatnot. It is a lot easier on the computer to do it as far as iterating in batches, which is why we use the training, testing, and validation loaders. So this is the what's called data loaders train. This just wants to show you the image and the labels for images and labels for one of the training and loading. So I was playing with this before, but I don't believe I ran this part. So I ran this part. That is finished. And running this part. And that is finished as well. Now, one thing I've noticed, a slight problem is for some reason I'm getting means, and well, this normalization should have everything between the ranges of -1 and 1, but for some reason everything within the tensor as far as the image is not between -1 and 1, which is throwing the helper off when it's trying to show the image. I will see what the problem with that is and get that back to you. Okay. But as far as everything else, these are correct steps. So now with the label mapping, I'm going to run that. So now you have names to the numbers which you are using as far as your encodings. So just run that now. We're ready to build and train the classifier model. Okay, so we're going to use a pre-trained network, and if you right-click on the pre-trained network and go to open, and you open it, what you will see is, Torch Vision gives you a whole bunch of different networks to train from, and just pick one of them. Of course, it shows you the error and whatnot. The bigger the network, as far as you have VGG11, and then you have the 13. The bigger the network, the better the accuracy, but also, of course, the more computational space you will need to train the network, right? So, of course, a bigger network should perform better, but maybe it's not necessary for the bigger network in this case. What I've already picked out is the DISNet 121. So I selected it and selected pre-trained is true. So get the parameters from the trained model. And then I write model just to see what comes up in Python. I'm going to run this line. It's going to load the model. And so now it shows me everything that's in the model, the layers, all the way up until the last layer, which is the classifier, which takes 1,024 features and outputs 1,000 different classes. So the model is trained with 1,000 classes. What we're going to do is use a different classifier, but all of the other parameters are going to be held constant, and we're going to use what we learned to train whatever was on these 1,000 images. It could have been animals, I believe. Whatever was on these 1,000 different classifications. We're going to use this model that was already trained in order to get the 100 or something flowers to see if it actually produces a good result. So that is the next step. what I'm going to do, well, I couldn't see that before, but I'm going to insert button sometimes. Okay, click this, insert cell below. So now that we have the model, now it's time to set all of the parameters to not do gradient descent, and it's time to obtain a new classifier layer, because we cannot use this classifier layer because it has 1,000. We want something that classifies to what we need. I believe it was 102. So we're going to the transfer learning solution. All right, so they already have their loaders. I picked the same model they picked, which is why. And okay, so now these steps are going to be similar for every time you use a transfer learning model with PyTorch. What you want to do is you want to freeze the model parameters and then set up a new classifier and then train the parameters that are on the new classifier to do the analysis. So do is copy and paste this to the new cell. So that is copied and pasted into the new cell. And what they have done is from the 1024, they went to 500, and from 500, they went to 2. Remember, we don't have 2, we have there we go. We have 102 flowers. So instead of the 2, we have 102 as far as our output. $102 as far as our output. So yeah, that looks good. So all I have to do is just press run, and it's all right. I'm going to insert a cell right here. Just insert another one as well. I think I might need 2 more. So now that we have created a new classifier, replaced that classifier, which I can show you. Click model and then click run. What you would see is when you scroll all the way down, what you will see now is the classifier. You have 1024 and 500, then from 500 to 102. Okay? And give me 1 second. Hi.
They don't have that app for it. What kind of cookie is this? Which kind of cookie is this? What are you looking at? Okay. Let me have one of those. And let me get a large.
All right. I am back. So, just making sure that we have the model correctly, which we do. So now we can do the next step. Which the next step is to train the model. what they have done already in here as far as transfer learning is they have set the device to CUDA if CUDA is available, and if not, the CPU. They're using the same architecture or the classifier. I believe this is a different model. They're using Dropout in this case, and they have the criteria and optimizer that's set for the classifier parameters. We're going to be using pretty much this. So the good thing is that if you went through the lessons and went through the PyTorch demonstrations, then this will be pretty straightforward and easy for you. So we do not need to reset the model and recreate a model again, but everything else we need, right? So we need the device, which if you've enabled your GPU, which I have actually enabled it for this lecture, then you'll be able to use the CUDA, which will make it run extremely faster. You have the criterion and the model classifier parameters will be the ones that we're training on. Everything else is already held constant, and we have model to device, which is what we need. We run this cell. All right, so the cell is run, model is to the device, and the next step, which is to be getting the epochs and batch sizes and everything for the model, which is how you train the model, of course. So just copy this and paste this. And so epochs 1 is really small, so let's use, let's say, 10. So epochs are a number of iterations throughout the entire data set you're doing as far as the training data sets. And you calculate the running loss from 0, and you're going to print the accuracy and the loss after every 5 steps. And so for each epoch, so you're going to be doing this 10 times. You're going to run through all of the images in the train loader, and each time you run through a set of images, you're going to count as a step. You're printing out the accuracy after every step. But what you're doing is you're going to get the inputs and labels sitting to the device. And here is your optimizers you're going to be setting, getting the inputs from the model moving forward, finding the log loss likelihood using the criterion, going to be back propagating that, and then calculating the running loss. And then, of course, if you're on one of the 5th steps, you're going to be printing out the accuracy and the test loss of the test set and the training set, I believe. So, actually just for the accuracy for the test set. So, after every 5, you're going to be looking at the test loading for each set. So that is what the accuracy is. That's what this part is going to be doing. Every 5, it's going to be using the test set to find the accuracy loss and whatnot. So running this, make sure all the parameters are set similar to, that's why we use test loader and train loader. Okay, so if we run this step, and notice also we use test loader for for this step, we probably should have used validation loader, but you have a test set and a validation set, so not that big of a difference as far as training potentially, but you should probably, just for the sake of clarification, use validation instead of the test loader, because validation is the set that you use to show where you want to start and stop testing. So, stop. All right. So now you have the testing. Hey.
Oh, I'm talking to my sister.
Yeah. Take you want
you want me to come over there? Who you talking to? 45.
So, like I was saying, you have a so now, well, this is running. This is testing. It has the epochs going, and we're gonna give that a little more time. But now also you want to validate exactly how good you're doing based on the test set. So pretty much the same exact thing that you've done as far as training, except you don't need epochs or anything. Just for each input. Probably easy if you get it here for each input. Just see exactly how it's going as far as the testing data set. So you're going to copy, and you are going to paste right here. So we're going to, for each input and label in the test load, since we're supposed to use valid loader up here, we're going to actually we could just use valid loader here. Hold on 1 second. Hey, if y'all gonna be loud, can you go somewhere else? I'm trying to get something done.
Go outside then.
Yeah.
I can get a picture or something.
So where?
You want to talk, go outside?
No, I'm trying to do something here. I'm asking you to move.
Well, don't tell us what to do. You can move.
No, I'm telling you to move, motherfucker.
You can move.
This is not a, I'm not.
Okay, then stay right there.
I am.
Okay. I ain't said no, I said right here.
You said what?
I ain't talking to you.
I got some ignorant buttholes in Starbucks right now. I apologize for that. I'm trying to deal with them when I can. So now we have the valid loader that is loading. It loads the inputs to your device, and we're going to be feeding the inputs forward. We are not going to be using the optimizer or the criterion for loss, the negative log likelihood. So we just need to do this. And remember, we also need to make sure the gradient is not running at the time. So actually this one, of course, no gradient. It's always good to make sure. There's also an evaluation mode as well as far as the model. So Control C. So now you have the test loss, the accuracy. It's feeding it forward, right? Getting the loss per item, calculating the accuracy. Okay, all that should look good. That is still running as far as epochs are going. Okay, and also the accuracy, of course, you want to do the accuracy divided by the length of the test loader. Actually, we just print out the whole thing, and we have test loss, and now we have the test loss and test accuracy as well. So all that should print the accuracy and test loss of the validation loader. Remember, in your code, you want to switch this valid with test and switch this test with valid, because you want to be using the validation set to see when your model should be stopped training. And this is actually running slower than what I imagined. Perhaps the GPU is not enabled in correctly in this case, but usually epochs run a lot faster. And you see printing after every 5 is perhaps a little too much given the size of this data set. So perhaps doing this after every maybe 500 or so might be a lot better. So yeah, so let's print after every 500 and do that. So what we have here is we have the testing. We're going to test the network in a similar way. And then we're using the if statement. And we are going to print that. So now the network is trained. We're going to assume that everything's trained as far as you have gotten the accuracy you would like with the testing set. And so now the network is trained. You want to save it and load it later just to make sure that works. That's what the point of this is. Okay, this is showing you how to also see the classes that are also provided towards the model as well. So what we're going to do is look at the transfer learning module.
I understand that one better.
And saving and loading models in Python is part 6. So it gives you great examples in part 6. We have the standard imports, transforming. They are showing an image. They are obtaining a network, training one, and then from here you have your model. You have your model state dict and keys for the dictionary keys, and what they're going to use torch.save their state dict to the file checkpoint.pth. Then they can load the state dictionary. What you want, not only do you want the state dictionary, but you want the model and its parameters as well. So instead of just doing that, what you're going to have is the entire checkpoint, which has your input sizes, your output sizes, which is the number of outputs. You have your hidden layers, and you have your state dict all inside of this dictionary right here. And what's also good is that with this checkpoint, you can also input the image loaders the data loaders that we needed from the previous point. So we have Control C. I want to save the checkpoint, Control V. And so now we have the checkpoint, which is the input size. What is the input size in this case? Our input size. Okay, this is going to be running for a little while. Let me just stop this. Okay, I'm going to stop this in order to get the input size, right? So the input size, since the first thing in an image gives us one of the inputs, then the image 0.shape is the input size. So what I can do is run this. So now we see the size, 3 by 224 by 224. All right, so we can use that. That is the size. We have the output size, which we have 102 classes. We have the hidden layers. So each .out features for each, and model.hidden layers are name of our our model is also called model as well, so we were all right at that point. And so now we save the checkpoint, everything in here. Oh, and we have also class 2 IDX. Okay, so we want to attach this as well. So in this dictionary, want to attach class 2 IDX, which is class 2 index, and that's going to have the attribute image data sets train class 2 IDX. So as opposed to just saving the state dictionary keys, now we also have everything, which is the class 2 index. We have the state dictionary keys, we have the hidden layers and the values, and we have the input sizes and the output sizes. It's a lot better to observe as far as training, right? So that is the checkpoint saved. Now we want to load this checkpoint. So write a function that loads the checkpoint. If we go to the learning modules in PyTorch, you see we have the load checkpoint. And so we have a file path, which is the file path we just created. It's going to take the checkpoint. It's going to load the file path. And now from the model, we have input size. We're going to create a model with input size, output size, and hidden layers. And we load the state dictionary with the load state dictionary and return the model. And that is it as far as saving and loading the model. So nothing on that needs to actually change. And then it says load the checkpoint. So all you do is just load checkpoint and checkpoint.pth. All right. And yeah, that should be good. Oh, the model. Of course, you want to call it a model. So if we call this loaded model equals load checkpoint checkpoint.pth. All right. And now inference for classification. So once you have the model, of course, but the main thing you want the model to do is to create inferences for want the model to create inferences for things that it has not seen before, right? So that is the key. How well can you predict the classes based on what you have trained on? So what we're going to do first is a couple of image pre-processing steps. So you want to use pill to load the image. So you want to use pill to load the image. Perhaps the inference section for the inference section has already gave you a pill documentation to load everything that you need. If not, then we will do it. Here, what you have is you have the same thing, train loader, test loader. They are making a network, connected network here. We're going to have the classifier, iterate over the classifier, and just take the top classes, one class in this case. You have a trainer, training the model, fitting. Actually, some of the these plots right here for the training and test loss would be great to use when you are trying to observe exactly what is going on and when to stop as far as the training and validation. Using this plot, of course, you will know, okay, your training loss is always going to be lower, but you want to stop when your validation is not improving as much. You see, this model does not have really good parameters or not a really good data augmentation or things that they can be doing to make this model train better. As you can see, there's not too much difference, as far as the loss to stop right here. A little short of could have been maybe 3 epochs, 4 epochs. So that's probably where you should stop training in this instance. If these are epochs, I'm sure these are. So yeah, the graph like this, which is what you should use to tell when you should actually stop with your epochs. So, run your first time. Usually, when I'm running it, I usually run like maybe 30 or so epochs, and then from there, I see exactly when it has stopped. Training really well on the validation, and once it's stopped, then I rerun it. Let's say the exact number, which could be 14 or 12. Do it with 12, and then use that as far as the model. You see, this looks a lot better right here. And from here, you would stop maybe around 10 or so. So you don't see anything as far as validation getting better, except after 10. So you stop training at around 10 in this instance. So no, I don't see anything as far as using pill for this. So since we need to use pill to load the image, and we have the documentation right here that we just open up and see. So here is the pill. Okay, so for pill, just import image. It's that simple. Okay, so that's all we. Of course, we also need the from statement as well. So copy and paste. And now we have the import statement right here. So, and the image will be the file path. Image will be the file path. Okay. So, and what else we need to do? Okay, resize the image where the shortest side is 256 pixels. So this will be done with thumbnail or resize. So open that in a new tab. So yeah, they've pretty much gave you everything that you need. So requested size, I guess you just put 256 into the image.thumbnail. I am got thumbnail and then 256. Okay. So that resizes the image to 256, and then you need to crop 224 by 224 portions, and that can probably be done if you hit Control F and hit crop. You would see you have crop right here, and box equals none. Okay, so this is for tuple box. Find the left, upper right, and lower pixel coordinate. So what to do is we have to find the left, upper right, and lower pixel coordinates. So we want the middle 224 by 224 portion. You know what? This might actually be easier instead if we convert this into a torch first, because up here, what we can do is we can transform the, to be honest, I'm not sure why they actually use the pill image instead of just using the transform. It actually doesn't make any sense whatsoever why you can't just use this, why you can't just use the image folder and what you're doing as far as training and transforming right here in order to transform in a similar fashion. But since it does actually to use pill, the thing I would do is find the size of this image. So we're actually at 753, so I have to actually stop. So I can write it right here. First, find the dimensions. So let's say you have a image that is, let's say, 256 by 250, right? So now you have that, and what you want to do is you, let's say for the 256 portion, you want to do 256 minus, what is that, 224? 224 is the amount of pixels that we need. So you have 256 minus 224, right? Divide that by 2. So now you know how many are going to be on the left, on the right, or the top and bottom. I'm not sure what dimensions are, right? You do the same thing for 250. And so now that you know that, you have 224 and 256 divided by 2, and that is what? 2, 3, 32. That's 16, right? So you want to start at, everything starts from 0 in the number array. So 16 all the way to 224 plus 16. And you're do pretty much the same thing with this dimension, right? So that's how you would get the center of an image. We are at 755. What I'm going to do right now is I'm going to stop. All right. And so now that is finished. Are there any questions? If you have any questions, put them in the group chat or put them in the Slack channel, and I will be able to see them. Definitely in the Slack channel. I'm checking the Slack channel right now as I speak. I'll give it a couple of minutes to wait for questions. All right, since there are no questions, I'm going to leave this. That will be the end of the lesson. All right, thanks for tuning in, and peace.